All right, let's get started, shall we? So welcome again. This is the Dynamo Office Hours Community Conversation. And yeah, welcome. Oh, happy to see you guys here. Move on to the next slide. So just for a few of you that might be new to this, Autodesk Community Conversations is basically an event like this where expert speakers from the community come and basically share their knowledge and do tutorials and demos and things like that. And also we sometimes get lovely internal folks like Saul and maybe Zachri, to be honest, not sure. But anyways, come and host and share all of their knowledge about different topics.
Yeah, Zachri is a customer.
Okay, even better. We love seeing customers come and share their expertise. So just a couple of things to go over in terms of the conversation itself. We can hop to the next slide. This is our safe harbor statement. I'm just going to pause here for a few seconds and let you guys read through it. Basically, what this says is just don't make any forward-looking or any purchases based on forward-looking statements, specifically anything that Saul or myself as employees say, and especially Zachri being a customer. So I'll let you guys just kind of read through this on your own.
Oops, that was hasty.
No, you're okay. It's a lot of words, but that's basically what that all says. So we can hop to the next slide. Quick introduction. My name is Tiana. I am a community program manager. I'm based in New Hampshire, and I am just here to make sure that this goes smoothly, and I'm here to monitor chat and things like that. So I will hand it over to the people who have much more interesting things to say, and let Saul and Zachri take it from here.
Cool, thank you, Tiana. So as noted just before, Jacob is not here today, so he's a ghost. He's here in spirit. He said he wishes he could participate, but he's very jet-lagged right now because he now lives in Sweden. Hurrah, which is kind of cool. So hello everyone, my name is Saul. I am a product manager working on Dynamo here at Autodesk. I like to describe myself as a curious human being, and I am based in Boston, Massachusetts. Over to you, Zach.
Hey everyone, I'm Zachri Jensen. You can just call me Zach. I'm a technology innovation engineer at Wood Rogers in Sacramento, California. We're a multidisciplinary civil engineering firm, so we kind of do all the things related to civil engineering, which is fun. I get to be involved in a lot of different types of projects, but my background is civil engineering, but I also happen to be kind of a bit of a geek, and I love Dynamo, so that's kind of the background to my little tagline there of engineered.
Thanks, Zach. And Zachri is also the package author of Canva, if you use that package. All right, so Dynamo Office Hours. Thank you all for joining us today. This is session number 46. So there's 45 prior hours of cool stuff to go check out. There is, I think, 5 hours of prior Civil 3D specific things to go check out, one of which Zachri has already presented around the API, which is awesome. And this session today is titled Blocking It Out, where we start to talk about blocks and blocks in the context of Dynamo and Civil 3D in particular. So like usual, we have roughly a 15-minute presentation, maybe 10 minutes today. We might be a little faster on the presentation side before we do a live demonstration, or to be more accurate, Zachri does a live demonstration. He's the subject matter expert here. I know the Dynamo stuff, and I've dabbled in the civil stuff, but not as much as he has. And then we have a Q&A at the end if we need it, but please do ask us questions the whole way through. We really enjoy having it as a conversation, and we prefer you to ask questions either in the chat or to come off mute and ask them live. So without further ado, over to you, Zach.
Cool, thanks, Saul. Hey everybody, first of all, I see some familiar names. It's great to see everybody again. So yeah, today we're going to be talking about blocks, and how we wanted to kind of kick things off here is just by saying, blocks are an essential component of AutoCAD. If you've used AutoCAD even just a little bit, you're probably already familiar with blocks and block references and how to create those and utilize those for having repetitive geometry that you want to all kind of control in a singular source in the block definition. And whether you're new to Dynamo or been a seasoned user, at some point at the beginning, you probably jumped into Dynamo and like, hey, what's this new tool? What can I do with it? And you're immediately faced with, at some point you run into this input that we've kind of highlighted here in the little green rectangle there that says block. This particular example is you're trying to create a simple circle and just stick it somewhere in model space. That's usually what you're trying to do, right? Is I want to create geometry in model space. So why do I have to specify this block input? And it may feel a little bit pesky and like it gets in the way sometimes. But blocks are an essential component of AutoCAD. Well, I'll say building block for a little pun there. But what you don't necessarily realize maybe when you are just doing things by hand in AutoCAD outside of Dynamo, whether you're just drawing lines or whatever, you are telling AutoCAD where you want to put stuff. Usually that's in model space, but sometimes that might be in paper space. And so in Dynamo, you have to do the same thing. If you're going to create anything, you have to tell Dynamo where in the world or what block do I want to put this stuff in. So that's what we're going to kind of explore today, is a little bit about what blocks are, and why these inputs are all over the place, and how blocks can be so powerful once you kind of understand how to utilize them.
Well, thanks, Zach. So now that we know why they're a little bit more essential, we need to talk a little about what a block actually is. And as Zach has alluded to, blocks exist in many different places, sometimes in your face and sometimes not so much. But conceptually, a block is basically a container to put things in, and a container that you can flex again in different places should you want to instance those blocks. Core elements of a block that exist are things like name, objects, base point, and attributes, although those attributes can be optional and don't have to exist. And inside of the block space, there is also some special blocks like things called dynamic blocks, which we'll touch upon a little bit later. But essentially, blocks are the building blocks, to use Zachri's pun, in AutoCAD, and you will be using them guaranteed if you're working inside of Dynamo, even if you're just touching model space or paper space, which are blocks themselves.
And that's a great segue right there. So this, for me, when I made the jump to just using AutoCAD with command-driven AutoCAD and exploring Dynamo, this concept of model space and paper space, this was kind of an eye-opening thing for me. So model space and paper space are actually both blocks. So what you're doing when you're drawing things in model space is you're essentially in the block editor for the model space block. And then for any other blocks, you're very used to maybe opening up the block editor and editing that block definition and then closing it out. That's basically what model space is. It's just a permanent block editor for model space. And then every layout tab that you have in AutoCAD is like the block editor for a paper space block for each one of those layouts. So what you'll see immediately in Dynamo, one of the really bread and butter nodes in Dynamo is just this document.blocks node that you see up there in the top right. And that just lists all the block definitions that are in your drawing. And you'll notice that the first two are always the same. They're always the asterisk model space, asterisk paper space. And then if you have multiple layouts, you'll have more that say paper space and they have numbers after them. But those two are always there in every AutoCAD drawing. You can't get rid of them, because if you did, well, what would we do? It'd be like getting rid of the world. So this is a core concept. Model space and paper space are blocks. So when you do things, you specify, okay, I want to put things in model space. Well, you put things in the model space block. This last bullet. To get a specific paper space layout, you can get the name of that block with a document, and then use the document.block by name node and put in the name of the paper space block, and then you've got the block for the layout. We'll dive into this a little more in the demo a little bit later, but high level concept, really important.
Awesome, thanks, Zach. So moving forward a little bit to blocks and block references. Apologies for the spelling. It looks like my font size jumped around a little bit here, but you can see that is actually block and block references essentially. So in terms, The terms block and block reference here can be used often interchangeably, but as Zachri mentioned earlier, you can think of a block as a container of things, and then a block reference is a reference to that container. Essentially, what we're doing here is we're defining something, and then we're bringing them to the party. And we can bring lots of them to the party if we want to have a loud one. So it usually doesn't matter when you're just working in AutoCAD or Civil 3D, but in Dynamo, it is actually kind of important to know the difference because you're going to be working either specifically with blocks or with block references. And so a block is the source of a collection of the objects, and a block reference really is the instance of a block or a copy of that block, if you will. And you can have numerous different copies of that block as a block reference, but you only have one of that block itself, which is that source. So one single source of truth and many different copies of that source of truth that you can do things with.
Not to be too pedantic there on the terminology, but a lot of times, what we're talking about here about them being interchangeable in, just your common everyday life. I mean, people often say, oh, I need to get all the blocks in model space or place a collection of blocks in model space. Technically, you can't do that. You can't really put a block in another block. You're putting a block reference inside another block. So it is pedantic, but like Sol said, when we start getting into, there are two discrete separate things, and that becomes apparent in Dynamo. And so it's important to know the difference.
Yeah, one cool thing to add is like when you start to dive deep into something like Dynamo, it does start to teach you more about the base application you're working in. So in this case, it's Civil 3D, or it could be any of our other hosts. And it starts to teach you about the way the program operates and works and how you can start to actually use it better, even if you're not using Dynamo, which I think is a fantastic learning tool just to get your head wrapped around how software in general, and then software specifically like Civil 3D, actually operates, works, behaves, and can be used in better ways.
Yeah, very good point.
All right.
Okay, coordinates. This can be where things start to get a little confusing, but we'll try to break it down, and it's pretty simple when you think about it. So basically, model space you can kind of view as like the world. So model space has a coordinate system with an origin point and X, Y, and Z axes, Cartesian coordinate system. And then like we've already established, model space is a block, and every other block that you define, or if you're in paper space, for example, same thing. It has an origin point, X, Y, and Z axes. So when you are working in model space, you're working in the world coordinate system. When you're working in a block or the block definition, you're working within the coordinate system for that block. So everything that you create within a block is referenced to the origin point and the coordinates relative to that block. And then if you place block references, you're now taking instances of that coordinate system and placing them in the world coordinate system. I think the key here is just the concept. It's really powerful of if you are working within the block definition itself, then you can work with the, I guess, nice clean coordinates just relative to that block's origin point, and then place all of those things in the world coordinate system that can have all kinds of crazy funky coordinates and rotations and whatever. And you don't really have to keep track of that or think about it too much, because you can always go back to that source definition and work in your nice kind of clean just XYZ coordinates for that block definition.
Yeah, so you'll see illustrated in the image here, we have red, which is that world coordinate system, which correlates to the red in the text, which is just X, Y, and Z. This could be considered like your 0, 0, 0 insertion point in Civil 3D. And then you have the ZM, ZY, or YM, and XM, which is kind of like that block reference, or the model in this case of that geometry, the reference point to that. And that's relative to each other. So the model coordinate system, or the block coordinate system here, is relative to that world coordinate system. Might be a little confusing to wrap your head around, but there are other instances or metaphors that we could probably pull out of the hat to help you get there. All right, making block references unique. So block attributes. These are what help make that uniqueness happen. And you need to understand which block reference you are going to use for computational workflows. It's really important sometimes to read those attributes in to then work with them downstream. So if you have that giant list of blocks that Zachri showed on a previous slide, you need to know which ones you actually want to use. And sometimes people don't name them in ways that are, say, human readable to the naked eye, especially if you inherit them from someone else or from another project. So you can use things like attributes to filter and find exactly what you're looking for. So an attribute really is like a label or a tag. It's essentially a little piece of information that attaches data to a block, and you can query those blocks by that attribute or by that data to do things, again, like filtering or using in downstream operations. You can also use Dynamo to programmatically query or set attribute values to block references. So this is one of the powers of computational design, is by sequentially sort of pulling in data and attributing that data to objects. In this case, it could be geometry, and pushing that back into your Civil 3D system with that attribute or information associated to it. So you can conceive of this as being something like taking a series of trees, understanding their orientation, and labeling them in the correct order, or doing the same thing with road and corridors or so on.
Cool. Okay. And then we mentioned it earlier, kind of another flavor of block is a dynamic block. You're all probably, well aware of what dynamic blocks are and how cool they can be to have adjustable parameters to actually manipulate the geometry individually for different block references. So that adds, beyond just attribution of having a single block reference, but then you can have varying attributes for that block reference. Dynamic blocks add even more, variation to that, where now you can have different geometric properties of that dynamic block, or, you may be familiar with different visibility states, having the block look completely different if you change those visibility states. So Dynamo has, the capability to query and set dynamic property names for dynamic blocks. Which is pretty cool, like Sol said, in a computational design environment, you can set those properties, dynamically based on other things in your drawing. Maybe you stretch a dynamic block based on some of the other things around it. Lots of power and options there. But there comes a little bit of a catch here, which Sol's gonna dive into on the next slide.
All right, so beyond dynamic blocks, there is a sneaky behind the scenes thing that AutoCAD does, which obviously Civil 3D inherits, which is a thing called anonymous blocks. And they are used to sort of handle different instances of dynamic blocks. You'll never see these in the UI yourself, just as a user, clicking buttons and working through the system, but you may come into contact with them through Dynamo, and they can be really tricky to work with. So a Dynamo graph can be built with, say, a dynamic block in mind, but if somebody in the Civil 3D sort of interface changes something, it could potentially blow up your graph. So Zach, I don't know if you've got any tips on how to work safely with anonymous blocks, but they are there at least, and you have to be very mindful of them.
Yeah, so let's look at this little example that's kind of just repeating in the bottom corner here. So what I did here is there's a dynamic block of just different cars. And what this graph is doing is the first node there, I've just selected the object. So that gets the block reference in model space. And then you see at the bottom, we'll let it switch back here. Okay, so initially right now, okay, the name of that block is, vehicles dash imperial. As soon as you change it to a different visibility state, now look, the name changed to this asterisk U184 name. And you might see that, and that's actually the name of the anonymous block. Because if you think about it, when you place a normal block reference, it just has a name. That's the block that it is referencing. And every single one of those block references is the same. And you expect that, right? If you go change the block definition, all the block references update, which means they all, they're all pointing back to that one source. With a dynamic block, you need to be able to handle different variations within the block references themselves. So an anonymous block is what AutoCAD is doing behind the scenes. It kind of creates these new little temporary dummy blocks or whatever with these new names just to keep track of all those variations. Dynamo will, it'll pick up on that and it'll use those anonymous blocks because that's actually what is in model space. The way to help your graphs out, if you go to the next slide, instead of like directly selecting that block reference in model space, a better way to get to it is, or let me back up. instead of selecting that block reference and then like working back upstream, I'll say, to get the block definition that's coming from, go the other way, start at the top and work downstream. So start with the overall block definition. In this case here, I'm just using the vehicles dash imperial, getting the block by name, and then getting the references of that block. And then you'll get more consistent results that way. This is something that's, it is sneaky, tripped up a few people. It's definitely come up on the forum a few times. This will help.
Yeah, so what Dynamo does is it starts to expose under the hood behaviors that software has that are imperative and really important for that software to function work, but typically have been handled in the UI in different ways. And most of those like safeguarding or guardrails that are put up around that behavior. And when you start to work programmatically with things, you have to be mindful of where UI-based guardrails are put into place, because we're not using the UI anymore for the most part when we work with building Dynamo graphs. So on to XREF, getting all the good stuff. This is my poor attempt at an inception-based image for XREF, but sort of like breaking news here. And XREF is also a block. As Zachri mentioned earlier on, everything's a block. And we have blocks within blocks within blocks within blocks and so on. So you can use Dynamo to access the objects in an XREF, just like any other block in the drawing, which means you can extract information from XREFs and work with it in the context of Dynamo, which is amazing without even having the XREF open. This is incredibly powerful. And it's incredibly powerful to start working with numerous different XREFs in a computational way when you need to pull out salient information, because as we've seen, you can start to query what exists within those worlds through things like attributes on your block references. So if you're looking to query and find, for example, particular blocks that exist within a drawing that you don't know where it exists within your system, you can do that potentially by querying all of these, all of the XREFs within the drawing that you're working on. The caveat, the thing you have to be mindful of here is that you can't actually edit the contents of an XREF from within a different drawing and save them back. So this is, again, partially one of those safeguarding practices, because you need to sort of be able to validate what is going on, and it could be incredibly disruptive or destructive, as the case may be, if you can start editing things all over the show without actually seeing what happens.
Okay, so block reference geometry. How do you, if you've got multiple block references kind of placed all around the world and model space, what if you wanted to get, you know, the actual geometry of those block references in their world coordinates, right? Like we talked about before, they're defined in the coordinate system of their parent block, but then when they're placed into the world coordinate system, now they're, you know, they might be rotated, funky, and scaled and all kinds of stuff. How do you get that geometry in world coordinates? Or, well, I should say into Dynamo, so that you can do something with that geometry, you know, maybe relative to some other things in your world in model space. There is a way to do it with just the out of the box nodes. I've kind of shown it here. Basically what you're doing is when you get the left node, I've just selected a block reference in model space. And then the top kind of green section is just getting the parent block from that block reference, getting all the objects within that block, and then getting their geometry. What will happen there, that with that object geometry node, it's going to be in the blocks coordinate system, which is probably going to be close to like the origin 0, 0. So it's going to stick all those things like in your Dynamo world at the origin, which is not really what you wanted. You wanted them in kind of your world coordinates. So what the pink and blue and then the final node there on the right, the transformation is basically taking, okay, I've got all those objects at the block coordinate system, transform them to the coordinate system of the, you know, the block reference, and scale them and everything, and then you're gold. This is 1, 2, 3, 4, 5, 6 nodes to get all that work done. There is a little bit simpler way to do it. If you go to the next slide, one of the you know, benefits of using these external packages is they can make our lives a little bit easier. So if you've used Dynamo at all for Civil 3D, you're probably already familiar with the Civil 3D Toolkit package. And there is just a single node in there called block reference extensions.getGeometry. That will get do basically what those 6 nodes are doing on the previous slide, kind of all wrapped up in one node. I think I actually stole your slide, Sol. What else did you have to talk about here?
No worries. I was just going to say, like, yeah, so out of the box is one way to do things. And typically out of the box behaviors today, but maybe not in the future, are quite granular, which means you're doing single individual operations. So if we just flip back to the previous slide, you'll notice, like Zach said, that there's like 6 different nodes to achieve a result. This is because you can control every single piece of the process along the way. Sometimes and often it's actually much easier and simpler to opt for the simple option, which is in this case, a package, the Civil 3D toolkit that has a simpler way to do this, which is taking those 6 different granular functions or behaviors or things that we're trying to do, just wrapping them up into a single node. So in this case, we're getting the block reference geometry from a block reference, and it's taking into account the transforms that are applied to it. So it's taking into account the geometry object of that block reference in relation to that world coordinate system and in relation to its own coordinate system, just doing it all for you. So it's only 2 nodes, which is simple to understand conceptually for you when you're trying to read the graph, or when you give it to somebody else, or when you even come back to it 6 months down the line, which makes for a happier experience, at least I think. And simple is often better than complex. So if you start to find that you're having graphs that are extremely granular in nature, maybe there's a better way to do it. Maybe the Canva package or the Archon Systems package or any of the other awesome packages that exist out there. Civil 3D Toolkit is another one, might actually have an answer for you that can help you clean up and simplify your graph. So opting for the simple options whenever you can, bearing in mind that some companies do prohibit the use of external packages because there is no, the onus on the package author to update is on their own time, essentially. So if they go on vacation and it's a critical project that you need and if something goes wrong, then it's kind of on you, whereas we handle out of the box stuff. But it is awesome if you're allowed to, and if you opt into that, to use these sort of simpler options to go and do things.
Cool. So placing block references. So like we've said earlier, blocks are such a key component of AutoCAD. You're probably very familiar with just sticking block references in model space. And usually when you do that, the by hand way that I've kind of put there in quotes is you pick the insertion point. Where do I want to put this block? Do I want to scale it a certain way? And then do I want to rotate it? Those are usually the 3 things that you have to define every time that you put in a block. It's pretty much exactly the same in Dynamo. You have to specify where do you want to put it? Do you want to scale it? And do you want to rotate it? So there's 2 nodes that do that. This top one is just block reference.create. You'll see that the top input is just the source block definition that you're trying to place the block reference of. Position is the insertion point. The normal is essentially a way to rotate it around. No, I'm not even going to try and figure out what axis.
It's an orientation. So you're typically like when you're working in a normal planar object of X, Y, you're going to be rotating around the Z axis that is kind of coming up off the page. And so that just gives you standard X, Y rotation.
There you go. Okay. And then degrees of rotation, any scale factors, and then what layer. And then at the bottom, you have another block input. This will kind of trip people up sometimes, is they've got the source block and then another block input at the bottom. Well, the one at the top is the block you're trying to insert. The one at the bottom is where you want to put the block reference. Could be model space. Most of the time it probably is. Could also be a layout, paper space, or even another block and have block references within another block. So that's what that does. There's another node at the bottom, block reference.by coordinate system. This one is actually a little bit more reliable. The block reference.create node, this may have gotten fixed. I don't know at the current status, but early on, is the block reference.by coordinate system node that is more reliable. That's the one I pretty much always use. And all it is, it's taking the position, normal, rotation, degrees, and scale factors, those 4 inputs in the top one, and wrap all of those can all be described by a Dynamo coordinate system object, right? An origin point, a scale, rotation, normal, all of that in one thing. So effectively, they do the same thing, but I recommend the bottom one.
Awesome. Sorry, I don't know if we lost you there for a second or we lost me. I'm unsure, but it was a little blurry on mine.
Okay.
I think if anyone has any questions, if we missed something salient, please do ping out in the chat.
Okay. In a nutshell, bottom node's more reliable. Use it.
Yeah. That's the red hand.
Yep.
Cool. So, all right. So creating blocks. This is the last slide before we get to that live demo. How do we actually create new block definitions? So currently, and there are some earmarks around this, but there isn't an easy way to create new block definitions using out-of-the-box nodes. Case in point here, there are a bunch of new Civil 3D nodes coming down the pipes at some point. Unfortunately, can't give you dates, but there's a lot coming. And in the not too distant future, there should be a lot more to work with out of the box. But today, there isn't really an easy way to do this out of the box. The Civil 3D Toolkit package does have a node, though, that can create these new block definitions from existing geometry, which you see here on screen. And there are a few limitations which that can enumerate on, but it is a pretty solid workaround. So the block reference, I don't know if you wanted to talk through this, Zach, or we want to skip straight to live demo.
Yeah, I guess I can talk a little bit about the limitations. So this node doesn't handle every type of geometry. So, or when I say geometry, I mean Dynamo geometry types to create the same AutoCAD geometry type. It handles a lot of the basic ones, lines, circles, arcs, things like that. I don't think it handles like NURBS curves, which would effectively be a spline in AutoCAD. So some of the more nuanced ones that you may not use as often, you might run into some issues with this node where it doesn't handle those. But for like 90% of the cases, it should get you there.
Okay, awesome. So we now have live demo. So I'm going to hand it over to Zach. I'm going to stop sharing screen, playing some ominous danger music. Here we go.
Yeah, for real, especially given that I was breaking up a little bit there. So try to interrupt me if you can, if that happens again, because that will definitely not be fun. Okay, I'm going to share my screen. Here we go. Thumbs up. Are we good?
We're good.
I'll move this thing out the way here. All right, so I'm going to go through, I've got like 4 or 5 different examples that we can go through here, and I'm going to move quick, but also step through a couple different graphs and step by step exactly what I'm doing to give you a couple of different examples of how to use blocks and block references in Dynamo. So this is the main file that we're going to be working in. Some of the elements that we have in here, we have a surface model. There's an alignment here with a profile being generated over here in the profile view, and then a corridor that's built, and a surface model also being generated from the corridor. You can kind of see it here. So this, maybe a little transportation focused example, but trying to hit a couple things here. I'm sure most of you, if you're in Civil 3D, you're often working with alignments, for example. So we'll do a couple examples there. And then I also have a few layout tabs here with some different sheets. So if you're a little more focused on drafting exercises in your job, I'll show you a couple examples here of using block references within like sheets, paper space and stuff. So first example we're going to do is, what I would consider kind of a hello world example for Dynamo. When you get in here for the first time, a great use case is placing block references specifically along an alignment at some fixed interval. So let me I'm going to hide a couple of things here just to clean up, make this a little easier to see. Okay, so there's our alignment, and we're just going to place some block references along the alignment and match the positioning of the alignment, the rotation, and all that stuff, just with a couple nodes in Dynamo. So move this over here, and then kick over to Dynamo over here. Actually, before I actually show that part, just quick little orientation. if it's your first time in Dynamo, looking for the nodes up at the top, AutoCAD and Civil 3D, you'll have different nodes for AutoCAD specific things. In this case, block references are an AutoCAD specific thing. Civil 3D objects like alignments, corridors, surfaces, stuff like that is under this shelf. Specifically for block references and blocks, some of the key nodes you'll end up using here under the document tab are block by name. That's where you can get a specific block in your drawing by its name. This blocks node right here gives you all the blocks in the whole drawing. Model space and paper space give you the model space and paper space blocks. And then if you go down to this object shelf, the first two here are block and block reference. So for block, you can import blocks, block definitions from other drawings. You can set the default attributes within that block. You can get the objects, you can get its name, etc. And then for block references, you can create new block references and work with their attributes and also get the source, like the parent block definition of the block reference. So every example I'm going to show you today is just using these out of the box nodes. Okay, let's collapse this and I'm going to open up my example here. Okay, so we're going to be just placing some trees along this alignment at a fixed interval. So we'll step through the graph. Let me make it a little bigger here. So here's the whole thing, but over on the left, we just have the name of the alignment, the spacing of these blocks along the alignment, and then the actual name of the block. In this case, it's some standard tree block that I pulled off the tool palette. So the first step we're doing is we're getting the alignment object. We're also getting the block definition for that tree, which is this document.blockByName node. And then this whole group here, basically what I'm doing is just getting the start station and the end station of the alignment and chopping it up into different little segments using whatever the spacing input is over here. And then we're creating coordinate systems along the alignment at that spacing, and then using those as the input for our last one here, block reference.byCoordinate system. So we plug in the source block for the tree here, the coordinate systems where we want to put them. I'm just sticking them on layer 0 for now. And then our destination block where we want to put these things is in model space. So we're getting the model space block here and putting it there. Okay, so let's run this. Whoops. I'll change this to automatic mode. Okay, so you can see here in Dynamo space, we have like, these are the individual little coordinate systems that are being created along that alignment and used as our input. And then here we go, here's all the trees placed along at those locations, the block references. So we can come over to the spacing and adjust that kind of in real time and see how those block references are being placed accordingly. Pretty cool. So now, what if we want to actually edit, the definition of these trees? Maybe we want to add some stuff to these blocks. Open up a different graph here where we can do that. It's basically just a matter of changing, instead of model space where we're editing things, we're going to now say that this tree block is the block that we're working in. We're gonna place some text within that tree block definition. So let me hop over to this one.
While you're opening that, Zachary, Ben has a question. I'll read it out to you.
Sure.
Is there a way to get the location or geometry of represented elements, i.e. corridors, in section views based on codes? Use case, get the position of a specific code in every section views and then use it for something, horizontal dimension from this point to another code, for example.
Yeah, I think I know what you're talking about there. So that would involve kind of, needing to work with section views and things. Though not with out of the box nodes. In my Camber package, I think I have some things for working with section views. But off the top of my head, I don't know exactly. So short answer is yes, anything is possible with enough time. May not have the specific nodes that you need for that task. But we can follow up the convo on the forum and maybe we can figure something out. Okay, so now we've got all these trees placed. We're just going to edit we want to add some text here to those and just edit the source block definition. And we just do that in one spot. And then all these will update. All the block references will update. So this graph, make it a little bigger. It's pretty simple. We're again, document block by name. We're getting that tree block. And we're just going to put some text in it that I've just said cool new text to make it really obvious. And now here's our output is some text. Instead of putting that in model space here, which would, be a common way to do it for this block input here, that block is now going to be our tree block. And the coordinates I'm using are just, I placed it to make it look good, but just X and Y, it's just 10 and -1, which in world coordinates, in model space, that would be very far away from our actual project, but we're working in the coordinate system of the block here. So I'll run this and you should see, okay, now you've got cool new text added to the block and it's all, if we go to the block editor for this, you'd see, there's where it's actually been added in the coordinate system for the block. But because we've accounted for all the rotation and everything, it's following the rotation of the alignment, which is pretty cool. And we can dynamically change this to some other text. And there you go. Pretty simple. You could do something like this with the attributes of the block. I'm just trying to showcase an example of editing a block definition and putting new things into it. Okay, let's do the next one here. What is my next one?
That's a good question.
Yes, we're gonna hop over to Paperspace now. Okay, so let me minimize this. What I have here, I have three sheets, very basic. Just got a viewport back into our model space world. And then I've placed these very egregious and kind of ugly notes everywhere. And they just have numbers in them. So these numbers are attributes. Okay, so this is one block. The source block is just called note. And then I have an attribute called note number in that block definition. And then each one of these block references has a different value assigned to those attributes. So what we're going to do is place a legend on this sheet that shows, all of the notes that are on the sheet and count up their quantities of how many there are. So, and that will vary depending on the sheet, right? So in this case, we have 2 with the 1. We have another 2 that share the attribute value of 2. We have 1 with 3 and 1 with 4. And then over here, we've got a whole different set of notes. So if you were to do this manually, you might find yourself kind of going through each sheet, counting those up, setting the value in the legend, and that's tedious, and nobody wants to do tedious work. So let's use Dynamo to help us with this. So let me open up.
Especially when people make changes.
Exactly. Place legend. Okay. So this one's a little more complicated. But it's, conceptually not too much. There's just, when you look at it, you're like, whoa, that's a lot of nodes. But I've grouped them here for you, and I'll run through basically what we're doing. First of all, we're getting all the blocks in the drawing, which is going to be, model space, paper space, all the trees, everything. And what I'm trying to do is just get the blocks associated with each layout, because that's where I want to put stuff. That's where I want to put the legend in each sheet. So we get all the blocks in the drawing, and then we just get their names. And you remember when I said earlier, paper space blocks, they all look, they're all named the same. They all say paper in them. So I'm just getting the names of all the blocks in the drawing, and I'm filtering to see, okay, does the name contain paper? Yes, no. We get rid of everything that doesn't, because we don't care about that, and we keep the ones that say paper in them. That's how we get the all the paper space blocks. The other thing we're doing is we're just creating, you know, basically the point where we want to put the legend, which you'll see when I do it, but it's going to be here at the bottom, just in this white space down here. And then the next, basically all of these nodes right here, what it's doing is getting these block references within each paper space block, and counting up how many there are of each attribute value. Okay, so pretty, easy to think about what it's doing. There's a few nodes that have a lot of filtering and sorting and stuff. So I'll post these things on the forum so you can go through them in detail afterwards if you want to, but that's basically what it's doing. And then the two key nodes that we've got here are this one. So the first thing we're doing is going to place the legend, which is a block reference itself. And then that legend has some attributes for the quantity of the notes in it. And then we're setting those attribute values. So we're kind of creating a block reference and setting its attribute values all in one. So let me just do it because I know I'm talking a lot. So we'll run this. Okay, so this is our legend block. I've done some very, very cheesy notes here. Install thing 1, thing 2, thing 3. Okay, but this is the cool part here is these are attributes, right? So if you look in our properties, we've got quantity 1, quantity 2, quantity 3, quantity 4, and Dynamo has populated those based on the count of things on the sheet. And if I go to the next sheet, we've also placed, let me minimize this legend, and those quantities are all different based on what is on this sheet. So we're handling the variation between sheets with the attributes. So I'll change this back to automatic mode. So this is just always running. And so as Sol said, how do we handle changes? If I change this to like an attribute value of 4, you should see this increment just while I'm right here. Oops.
Sorry,
there you
can
go.
I
See,
ask a question?
Yeah.
Yeah. So for example, if you have those markups inside an external references, you will also be able to quantify those if you use a drawing definition with only the sheets. Can I quantify those from an external reference as well?
Yeah. I think in theory you could do that. It might, if that reference is if that XREF is in model space, then it would be a little, the tricky part you'd have to do is how do you figure out, that only let's say these are in your XREF. If those are in model space, then you kind of have to figure out, are they actually contained within this viewport?
Yeah.
Because if you just get the block of the XREF, then you'll get, you'll essentially be counting up all of the notes, in your whole project, not just the ones that are on this sheet. So you kind of have to do some spatial geometry that say, does this note fall within the bounds of the viewport, which gets a little tricky.
Yeah, but it's possible to get the bounds of the viewport.
Yeah.
Sort of. Yeah. Good. Yeah.
I think you can probably do that with a containment test.
Yeah.
Because if you have an insertion point for each of these nodes, there's a polygon dot containment, I think, node, which you can use to say, does this sit within a polygon? And if that point is true, yes, then you know which sheet theoretically it's on. You do a little bit of pairing.
Cool. So let's do an XREF example. I do have one more for the XREF. So let me close this one.
Yeah, we have about 5 minutes left, so I think just enough time. Perfect.
All right. So I have another separate drawing where you see here what I've already done ahead of time is placed. These are blocks for like light poles along our alignment here. Okay. So this is a different drawing, and then I'm going to XREF it in here really quick. Okay, you might have a hard time seeing it, but there you see there's the light poles. Okay, so now what we want to do is, I'll put the surface back. Let's say this can, I'll show you an example of how to do coordination between disciplines, right? So maybe you're working in your 3D design file here with the corridor information, and you have some data from your, traffic design team or whatever that placed these where the light poles need to be. Well, maybe I want to place actual 3D objects of the lights, in this drawing with like 3D solids to show them at elevation and how they relate with the topography. So we'll go into 3D here. Hopefully things don't crash on me. Make this easier. Let me actually turn off the make the drawing a little bit easier here. Turn off the corridor. It's a little bit heavy. Okay, so now we just see our surface model of our new road. Okay, so we want to place the 3-dimensional light poles, at elevation, but at the same coordinates as the XREF, right? So, in the sake of time, I'm probably gonna skim through this a little quickly, but I'll show you how it works. Place luminaires. Here we go. Okay, so essentially what we're doing is we're getting the XREF block definition, right? So I just get all the document.block by name again, and then I know the name of my XREF is called luminaires. And so I just get that block, get all the objects within it, which will give me everything in the drawing. I filter out, I just want block references, okay? So that gives me the light pole block references. I get the insertion point of those block references, which will be in, our world coordinates. And then I get the elevation on the surface at those points, and then create new block references for the 3-dimensional light poles at those same points. Okay, so let me make this. Okay, so we'll put this here and change this to automatic. Okay, see? So this is really cool because this data is being driven by the XREF. So then if I go back to the XREF, and let's say, just to make this really obvious, I'm just going to delete, a bunch of poles, which I don't know, sometimes these things happen, right? Okay, so let's say we don't need those anymore. The design is updated. I'll just save it here, come over back to the example, and I've got, oh, you can't see it here because my name's in the way, but it says the XREF was modified. So I'm going to reload it. Okay. And then the Dynamo graph, I need to rerun it, sorry, on my other screen. Okay, now you see all of those poles are now gone because it's all driven by the data in the XREF. So super cool. There's way more that opens up, when working with XREFs. You can get any geometry from the XREF into Dynamo, and maybe you could do like, oh, maybe I'll get all the conflicting, intersection points between pipes in multiple XREFs or something like that. There's a ton of possibilities there. So we're out of time here, Sol. So I'm going to stop sharing my screen.
Sounds good. There was one question
Yeah.
from Edward, which was answered by Sven correctly. So are the block references placed in the layout example, or were they placed in model space and you're just seeing them through the viewport? They were placed in paper space, correct?
Correct.
Yes. Yeah. Awesome. All right, so I will share my screen really quickly to wrap this up for the end of today's session. But if there's any other questions, please do sing out inside of chat. Otherwise, we have a couple of extra sessions upcoming. The next one is on May the 4th. So for the Star Wars fans amongst, we're calling this one Awakening the Dynamo Force. We're going to have a mystery special guest on this one, still mystery. I haven't quite locked that one in yet, but we have some contenders. And that is going to be around transferring data between different places. Specifically, we're going to start talking about how to work with Tinkercad and start playing with information from Tinkercad. Now, I'm not going to be here for that one, but Jacob will be back leading that one. Then we have on the 18th of May, Taming the Chaos. This one is going to be taking a Dynamo graph that you might have found on the forums or been given by someone else or something from your sorted history when you first jumped into Dynamo that may or may not be chaotic looking and confusing, and you want to maybe tame it a little bit and add documentation and clean it up. So we're going to take the graph and clean it up. And then getting on the same page essentially is talking about documentation. So like, how can we actually have a correct graph sent to another person in a way that is sensible and makes sense, clean, easy to read, easy to understand for other people or your future self. And then many more cool things to come after. Over to you, Tiana.
Great. Well, first of all, thank you for a great session. And if anyone who is on the call wants to get involved more in the community or host one of these themselves, you can go over to the community conversations page and send in a proposal. On the screen, there are other ways to get involved in the community as well. So definitely, if you are interested, don't be shy and go ahead and get involved. I believe that is everything. So again, thank you all for coming. And yeah, thank you, Saul. Thank you, Zachri, for an awesome session.
All right. Yep. Big shout out to you, Zach. Thank you so much for putting this together and being the expertise on the call today. I was just along for the ride. And thanks to everyone for coming and listening in to how to play with blocks in Civil 3D and Dynamo.